Okay, good morning, guys. Happy Tuesday, January 16th. We are at day 11. Wow. That means we got 7 more teaching days. No, actually 6 more teaching days because I don't really count the last one. By then your mark should be already done. Okay, so let's get right into it since it started later. We acknowledge we are hosting the lands of the Mississauga of Anishinaabe, the Haudenosaunee Confederacy, and the Wendat. We also recognize the enduring presence of all First Nations, Métis, and Inuit people. Okay, so today is Tuesday, July 16th. This is what's happening today. Your Unit 4 test, okay, highlighted there. 3 parts. The hot links are going to be there. Okay, it is tomorrow, July 17th. Okay, but it's also at 12:01 a.m. That means at night. Okay, that means 11:59. If you wait 2 more minutes today, wait 2 more minutes, and then it'll be open. So you can work on it in the middle at like 2 o'clock in the morning if you want to, right? Don't just say, "Oh, I'll wake up at 8, 9." You can wake up at 2 o'clock in the morning and work on it. It's up to you. Okay. I'm just giving you like notice. So you better understand the time. See, 12:01 a.m. Okay, and it's then due tomorrow the same time, 11:59 p.m. So you have the whole 24 hours to get it done. So I still wonder when people don't get it done and have extensions. You can do it. Start working in the middle of the night if you want. Okay, like I'm giving you flexibility. Some people work or whatever. So they gotta stop. Like if you miss a test, it hurts you, right? You get 0. So please don't do that. Right now we have Unit 4 test, and then we got a Unit 5, and then collimating. I haven't marked the Unit 3 test. So the midterm, like you got, doesn't include Unit 3 test. So you know that. So hopefully your mark can go up, or it stays the same, or if you got an 80, maybe it'll go up from 80 to 90. Okay. So today we're going to talk about periodic behavior, periodic functions, transformation, sketching, sinusoidal graphs, applications of sinusoidal graphs. Okay, I have a technical issue happening right this minute. Give me a second, guys. I'm going to pause my recording. Hold on. Okay, guys, I'm back. A disaster was about to happen, but I'm back. Technical issues are fixed now. So let me make sure I see what you guys see. So I'm gonna change it into student view up here. So just making sure I know what you guys can see. So this is viewing as a student. Okay. So again, we're gonna go into content. And chapter 5 is showing up soon, but we're not there yet. So we're gonna go into trigonomic functions, and we're gonna go to July 16th. That's where it starts. So there you go. We have July 16th. And then we are starting at periodic behavior. Okay. Some of these, again, there's no video, so I'm just going to teach you it as we go. So we're talking about periodic behavior, okay? And we're looking at, this is a sinusoidal cyclical graph, okay? So let's go into it here. Okay, so modeling periodic behavior. So first of all, let's look at the definitions. Zoom in a little bit. Okay, a periodic function, and so that's what we're looking at. Is a function that has a pattern of y values that repeats at regular intervals. That's important to understand. It's a function where the y values repeat at regular intervals. So if I'm gonna have a graph here, okay, if I go like this, you can see my y's are increasing or are repeating, right? Right, at some point, it repeats. When I get to here, that point was like over here, so it repeats. There's a pattern, okay? That's what we're saying, this graph here that's repeating, that's a periodic function. And it has a cycle, okay? And the cycle is how long it takes to complete one pattern. So if my pattern started here, and then it looks like it repeats over here. So from here to here is one cycle, because then it repeats again, okay? Then you have a period. The period is the length of the one cycle. How long, like what's the X value, okay? And then you have the amplitude. The amplitude is the distance from here to there, okay? All right, is the halfway distance between the max and min of periodic. So here would be also an amplitude, right? That distance there. Okay, so that's what we're looking at. So let me clear that. Let's go on to the next set of points. So, recognizing properties of periodic function. How to find the period of a function. Okay, choose a convenient x coordinate to start. So when we say we're trying to find the period, we're trying to find the length of the one cycle, okay? The period is the length of one cycle. So choose, so if we're saying length, that means looking at the x-axis. So choose a convenient coordinate to start on the x-axis and then move to the right and estimate where the cycle begins. Find the difference between the x coordinates. So for example, I'm looking at this graph here. I choose here. This is like a sinusoidal function, a periodic function. You can see it's like it repeats. So from here to here, it's one way, and then it repeats again from here to here. You follow my mouse, okay? So then over here, I pick this point as a starting, and then over here, it looks like it stops. It starts again. It ends and starts again. So now the difference between from here to here is -6. So my period is, I go from 0, I just subtract the distance. So my period is 6 units, or whatever, whatever units that would be, okay? So that's my period. Now, if I look at this function here, there's no pattern. So since there's no pattern here, this is not a periodic function. It's all random. It does, maybe if this was bigger, maybe we'll see where it would repeat, but it doesn't repeat here, not from what we see. So therefore, this is not a periodic function. This one is a periodic function. This one is not. And now let's look at this one over here. So when I look at this one here, the question is the function periodic? If so, what is the amplitude? Okay, is it a periodic function? It repeats, looks like. These things look like they repeat. So from here, come down, go up, come down. Okay, it looks like it repeats here, right? So if I start here, and then I go to here, it repeats, right? So this is a periodic function. Now, what's the max and min? Well, the max is up there and the min's down here. So the amplitude is basically getting the difference between the max and min. So if my max is, if I count this as 3, and my min is -1, so the difference between 3 and -1 is 2. Okay, so that's my amplitude. Now when I go into the next question here, this example here, the following periodic function determine the period and amplitude. So now I have to find the period and amplitude. So the period is the length of the cycle. The amplitude is the distance between the max to the midpoint, or the min to the midpoint. So, or just the difference between the max and min divided by 2. Okay. So let's look at our period. We got to see where it repeats. So we start here. And if you follow my mouse on the screen, it starts here. Okay, maybe I'm going to use a different color so you guys can see. I'll use so many repeat colors. I'll use orange. Okay, so it repeats here. It starts here. And then it looks like it repeats over here. Sorry for this sound in the background, guys. So then I start off at -7 and I go to -1. So that is where it starts and ends and repeats. I didn't even have to do this. I could have did from here. I could have went from here and then I go over here. So I would have said -1 and 5. -1 and 5, the difference between -1 and 5 is 6. The difference between -7 and -1 is 6. So you can see it's still the same value, okay? 6 units. My amplitude, my highest is 3, my lowest is -2. So what I do is get them, subtract the 2, and then divide by 2. So 3 minus -2 is 5. Divide that by 2. My amplitude is 2.5. I know they just leave it as a fraction. You can do that, but the amplitude is 2.5. Okay. So let's go to the next one. Okay, so this one here for the following function. This is the function here. Determine the y when x is 2. Determine this is what this means. It means determine the y when x is 2. Remember, we're saying function now, so it's f of 2 and f of 5. So determine y when 5 is 2. Well, I'll have to just go on the graph and say, well, when x is 5, y looks like it's 0. Okay, there you go. When x is 2, y looks like it's 1. That's what you see there. So that's straightforward, right? We don't have to go into details of that. That's so easy, right? Let's look at, here's a problem question. Okay, so with this problem question, you can see that, let me minimize this. So I'm looking, and this is where we get into what is a periodic function. And so a periodic function is when things repeat, right? Something's repeating. Here, with this question, it's showing you where a machine is repeating an action. The machine is repeating an action. So here it is. A cutting machine chops strips of plastic into appropriate lengths. The following graph shows the motion of the cutting blade of the machine in terms of time. Okay, so if I'm cutting strips of plastic, I want to make those strips of plastic the same length, right? So in order for me to cut it to the same length, that means my blade should be coming down at the same time, right? So every 5 seconds, it should be, if I'm going like this, going along, maybe you can see my hand. Let me see if you can see my hand. If I'm going along and I cut it here and come back up, then I cut it over here, go back up, I should come down the same time. If it took me 3 seconds to come down, I should be doing that in a repeated way. And that's what's happening here. Okay. So it's a periodic function because my X or my Y, which is maybe my height, is coming down and going up. There's a cycle. Okay. And then maybe the cycle is based on the time. Okay. So here we look at this one here. So the blade is up, that's the max height, and the blade comes down, and it's the height is 0, and goes back up, and then it waits, and then it comes down and goes back up. Okay, so you want to know what the amplitude is and what's the period. Okay, so it says here, and now the first question: state the height of the blade, the min height, and the amplitude. Okay, the height of the blade looks like it's 0.5 off the ground or off the table. That's the height or the max height. The min is 0 when it hits the table. So our amplitude would be the max height subtracted from the min height, which is 0, divided by 2. So our amplitude is 0.25. Okay. Now the next question is, what is the period? The period is the time for the one cycle. So I'm up, I go wait, down and up again. So from here to here, what's my time? How long it took for that cycle to repeat, to start repeating? So I can look at here, well, I start at 4 seconds, and then I'm back again at 8 seconds. So my period will look like 8 minus 4. My period would be 4 seconds. So that means it takes 4 seconds for this to repeat itself again. Okay? There you go, 4 seconds. Now it says here, state the next 2 times where the blade will strike the cutting table. So if I'm saying the cycle is 4 seconds, right? The cycle or the period is 4 seconds. That means every 4 seconds, I'm going to come down and hit the table, right? It's saying what? What's the question? When it strikes the cutting surface. Okay, it strikes the cutting surface at 7.5. Okay. Strikes the cutting surface at 3.5. I know my cycle is 4 seconds, so if it strikes at 7.5, add 4 seconds to that, that means it would be what? 11.5? Add another 4 seconds. It would be, there you go, 11.5, and then another 15.5. That's when the blade hits the table, and that's when the height is 0, right? So wherever the height is 0 is where it hits the table. So, and that's going to repeat every 4 seconds. Okay, so that's easy. Okay, so that is the first lesson. So let's go on to the next one. Oops, my bad. Okay, give me a second, guys. Some issues with the mouse. Okay. Okay, so then there's worksheet questions for that. Graphing, let's get into graphing. Graphing, sinusoidal, and we kind of talked about it in the previous lesson, but we'll look at it here.
And welcome back to this U.S. Open office plan.
Miller just lobbed a message way over Jones's head using some technical jargon.
So there's video for this, so let's look at the video.
Ooh, and Jones brings the heat with a per my last email.
They need to.
Let me just get into it. Okay, hold up. It's no sound.
Origin with the radius of 1.
I want to pause. Could you guys hear that? You guys hear the video? Did you guys hear the video? Okay, so now we're looking at the graph, and you can see here, yesterday we talked about unit circle, right? And we talked a little bit about the angles in a circle, right? Now we're going to see how it relates to a sine graph and a cosine graph, okay? So you're going to see how it relates. So here we go.
How we can rate the three primary trig ratios to this unit circle, and then use that relationship to help graph what sine theta and cos theta actually are going to look like graphically. So we'll graph sine theta in yellow there. We'll graph cos theta.
Okay, so that's the sine periodic function, right? The periodic function is either going to be a cosine or a sine, okay? And that's what we're trying to graph. And you're going to see the graph how it can come off from your unit circle or your circle that we talked about yesterday.
In green down here. But first, let's remember the relationship between the primary trig ratios and the unit circle. So keep in mind, three primary trig ratios are sine, cos, and tan. And you know the word SOHCAHTOA tells you that sine of any angle is equal to its opposite side divided by the hypotenuse. Cosine is equal to adjacent over hypotenuse. And tan is equal to opposite over adjacent. And
okay, he's going to get into it, but I just want to just show you what he's going to actually get into. So here is my line on my unit circle. That's your radius, right? And if we make a right angle triangle out of it, okay, right? So we know that point there on that corner there, right, is made up of X and Y, right? Because we're on a graph, right? So X is down here, Y is up there, right? And then this arm here, we call it the radius, okay? So, and if we're looking at the angle from here, right, we can use our SOHCAHTOA to figure out, you know, if we know what R is, and R, since it's a unit circle, R is actually 1, okay? Okay, so R equals to 1 in a unit circle, okay? So that's key now, because we're saying R is equal to 1 and it's a unit circle. So when we are trying to figure out what X, what Y is and what X is, right? We know R is 1, what Y and X is, but we don't know the angle, or we say we do know the angle, then we can figure out what Y and X are, right? But based on SOHCAHTOA, if I'm looking at sine theta, okay, that would equal to opposite over hypotenuse, right? And we know the opposite in this triangle here is Y, right? And our hypotenuse is R. But wait a minute, didn't we say R is equal to 1? So then sine theta is just going to equal to Y, right? Because we already said R is equal to 1. right? And then similarly, if we're doing cos theta is going to equal to adjacent over hypotenuse. And then we know the adjacent is x, and the hypotenuse is r, but we said r is equal to 1. So we know that. So cos theta will just equal to x. Okay, so interesting. Cos theta is equal to x, and then sine theta is equal to y. Okay, so now that helps us to figure out this value here is actually just sine theta. See, my x, sorry, my bad. My x, and I'm gonna use a different color here so I can tie it all in. My x is actually equal to, and follow there, is equal to cos theta in the unit circle. And my y is equal to sine theta. Okay, that's what we have here. And that's what we have over here. Okay, he's going to explain all that. I just want to give you a heads up so you guys can see it and hear it a couple of times. Okay, so that's what that is right there. So that's going to help us to do our graph. Okay, so let me clear that, and then we'll play the video.
And this was used for when you had right triangles where your reference angle was in here and the reference angle was less than 90. And that reference angle, we could label our opposite, adjacent, hypotenuse. So this is great when your reference angle is less than 90. But the unit circle can be used to look at the relationship between angles and the trig ratios. When we have angles anywhere between 0 or 360, we could even use negative angles by rotating clockwise. Or we could do angles bigger than 360 just by continually rotating around this unit circle. So how are we going to use this unit circle to get a new relationship for the primary trig ratios? So first of all, remember that the initial arm always starts along the positive x-axis here. And then our terminal arm is going to rotate counterclockwise around. So we could draw our terminal arm is going to rotate.
Okay, so he's drawing the terminal arm, right? And he's setting it up that now this can move around, and we can determine based on where it hits the unit circle, we can determine our points over here that cuts the unit circle. Okay, so let's go.
Some angle, we'll call that angle theta, from the initial arm in a counterclockwise direction. Now it's going to intersect the unit circle at some point xy.
Okay, see that is getting to the point xy, and that's what I was saying, a unit circle. And when it hits the unit circle, that point there is xy. So here we go.
Here. Now if I were to make my right triangle by connecting this back down to the x-axis, in this right triangle, this side, well, let me just erase this here so you can better visualize this right triangle. This side has length x, right? Because to get to this point here,
right, this is what I talked about. This slide is length x, and then over here is length y. And then based on looking at that angle, this would be the opposite. X would be the adjacent. He's going to talk about that.
we would have had to travel x units that way and then y units this way. So this side has length y. And this side, the hypotenuse of the right triangle, is the length from the middle of the circle to a point on the radius of the circle. So this, since it's a unit circle, the radius has a length of 1.
Okay, so the radius is the length of 1. Okay.
So we can rewrite our primary trig ratios in terms of x and y. So sine theta would be equal to the opposite side, y, over the radius of 1.
Okay, so he's basically writing the formula that I just showed you guys earlier. Okay, and if I fast forward, there you go, sine theta equals to y.
Distance between the x-axis and the point that intersects the unit circle. Cos theta.
So he's going to do the same thing for cos theta, right? So cos theta is going to be equal to adjacent over hypotenuse. Hypotenuse is 1. Our adjacent is x. So it's going to equal to x over 1, which is just equal to x. Okay, that's what you see there.
Just x. So cosine actually just tells you the horizontal distance you are from the y-axis. So let's use these relationships so we know that sine theta equals 1 and cos theta equals x. Sine theta equals 1, cos theta equals x. So let's use that relationship to be able to actually figure out what the ratios are going to be at some key points as we rotate around this unit circle. So let me just get rid of all this. So we are going to start along the initial arm along the positive x-axis.
Okay, so right now we're looking at how, as we go around this unit circle, as we go around, how it's going to be related to our periodic functions here, where we have y is equal to sine theta and y is equal to cos theta. We're going to look at the y is equal to sine theta first, right? So over here in this graph over here, we have numbers. Well, these are the angles: 90, 180, 270, 360. So these are angles on the x-axis, and on the y-axis, it's actually your unit circle value. So our unit circle, our highest number is 1, our lowest number is -1, right? So if I'm looking at this unit circle, if I were, this unit circle, but it's on a graph, if I'm looking at that, then what I'm going to see here, if we were to label the points on this graph, right? Let me label it, give it a different color here, purple. So that point there, over here, that would be 0 for the x, right? My bad, not 0 for the x. That would actually be 1 for the x. Let me just fix that. That would actually be 1 for the x and 0 for the y, right? When you think about that coordinate right there, right? And if you think about that coordinate right there, well, we said it's unit circle, that means this is 1. So that means, but then I'm at 0 for x. So my coordinate there would be 0 for x, 1 for y, right? And if I go over here, my coordinate over here at that point would be, okay, my x is on the negative side, so this would be -1, and then my y is at 0. And if I come over here, my x now is at 0 again, but my y is at -1. Okay, so these are, now if I rotate around, this is a circle, so I can go around 360, right? But if I get to this angle here, if I rotate to this angle here, looks like that point I have, my y value is going to equal to 1. And when I come over here, my y value is equal to 0. When I come over here, my y value is equal to -1. And come over here, my y value is equal to 0. Okay, so it goes, my y goes from 0 to 1 to 0 to -1 to 0. So I can say it repeats after it does a 360. Okay, you're gonna see, if I were to plot, this, the unit circle versus the angle, I can say I start off at 0 for my, when it's at angle 0, I start off at 0, but when I'm at 90, right? When I'm at angle 90, I'm at 1 on the unit circle. Okay, and then I'm at 180, I'm at 0 again on my unit circle, and I'm at 270, I'm at -1. You're going to see this pattern now, and then I'm at 360, I'm at 0 again. So it looks like this. Okay, this is kind of bad drawing, but it looks like that. So that's, you can see my periodic function now, right? So He's gonna explain that just like I just did. I just wanted to give you guys a preview to see what's he gonna say. Okay, so let's continue. I'll probably keep this on for a little bit.
So that is going to intersect the unit circle right here at the point 1, 0. And we're going to graph the ratio for sine as we rotate 360 degrees around this unit circle. So if we are going to find the ratio for sine theta, remember sine theta is always equal to y. So if I want sine of 0 degrees, I just need to look at the y coordinate of where it intersects the unit circle when we've rotated 0 degrees from the initial arm. The y coordinate is 0. So sine of 0 on the graph is going to start right here. It's going to have a sine ratio of 0. What if we want to do sine of 90 degrees? What if we rotate 9 degrees and now it's going to intersect the unit circle right here at the point 0, 1. Well, the y coordinate of that point is 1, so sine of 90 is equal to 1. So when we've rotated 90 degrees, the sine ratio is now 1. And now that's the furthest we're ever going to get from the x-axis as we rotate around the unit circle. So the biggest the sine ratio is ever going to be is 1. So when we've rotated...
So you can see here, we're basically rotating around, and we're gonna connect. So if I'm looking at, you know, my sine of the angles, so sine at 0, we know my y value, a sine at 0 equals to, because this is what we're saying, the y values are my sine theta. Okay, so this is the main thing I'm gonna just write on the screen here, and I want you guys to see that. Okay, so our coordinates on the unit circle. Okay, let me go to here. I'll use green. So our coordinates on the unit circle, okay, are made up of our cos and sine. So we said here cos theta, right, equals to x, and sine theta equals to the y value. So if I know my angle, if I say my angle is 0, right? So each of these are x and y, or each of these are cosine theta, sine theta. If I plug in here for sine theta 0, like we do over here, my angle is 0. Sorry, my angle is 0. If I plug in angle 0, therefore my y value is 1. If I go over here, if I plug in my angle is 90 degrees up here, if I plug in my angle is 90 degrees, then my y value is 1. If I plug in my angle of 180, what's my y value of angle? If I plug in my y, I'm going to just ask that question in the chat. Someone just tell me if you guys are paying attention. If I plug in 180 for my angle, so sine of 180 is equal to what? Let's see who's following. Sine of 180 would equal to what? Sine of 180 would equal to what? 0. Thank you. Yes. Ding, ding, ding. Right? Sine of 180, right? 180 degrees. This is such a bad handwriting. Sorry. You know what? Let me not do like that. Right? So sine of 180 is going to equal to 0. So the next one would be, so sine of 270 is going to equal to, crunched over there. Sine of 180 is going to equal to what? Sorry, sine of 270 is going to equal to what? Someone help me out. What's sine of 270 going to equal to? Anyone? Tell me in the chat. -1, that's right. So you can see the pattern now, okay? So that's good, you see the pattern. So here we go. I'm gonna fast forward a little bit. Actually, let me clear the screen. Ooh, saw some lightning there. Okay, there you go. Sine of 180 is 0. Fast forward again. And you can plot it. You can see he plots it over here on a graph. Sine of 270, right? Sine of 270, right, is -1, okay? And then sine of 360, well, sine of 360 is probably going to be what? 0, right? You plug it in, see where he gets the sine of 360. Okay. He doesn't actually, yeah, he plots it there. Okay. So then that's it there. 0.
0, so the ratio is back to 0. If we connect these points, I mean, we could find points in between these, maybe using our special triangles. You would figure out that it's actually going to form a curve like this. The points are going to be connected by this smooth curve. And this is what the graph of sine is going to look like. Now, and it's going to continue. Remember, this function is periodic. So this pattern of y values oscillating between 1 and -1 is going to continue every 360 degrees.
Okay, so the period is 360 degrees, right? So the amplitude is 1, okay? 360 degrees is the length of the one cycle. So one cycle is 360. The amplitude is 1, okay? And then you're looking at the cosine. Cosine is dealing with the x component, like I said. So if I'm looking at cosine of 0 degrees, well, I know cosine of 0 degrees is going to be 1 based on my graph. Cosine of 90 degrees, cosine of 90 degrees, that means it's going to be 0, right? It just tells you everything there based on the unit circle. Okay.
And we could also rotate in the negative direction.
So let's get into him talking about a cosine.
Coordinate of every point that intersects the unit circle. So at 0, the x coordinate is 1. So the cosine function is going to start up here at 1.
Okay, so it's at 1, it's at 0, it's at -1, and then it's at 0, and then back to 1 again. So then those are going to be the points you plot here. And if you do that, there are the points there, fast forward. So that's what it looks like there for the cosine. And then it repeats every 360. Okay, so that is that lesson. Okay, so that's how you do the graphing. Okay, there is worksheets related to that. And then I think the last one is, we don't know how much time we got. Let's look at, transformation. Okay, so now we know there's transformation for these periodic functions. We have transformation for exponential functions. We have transformation for regular polynomial functions, right? So there's always transformation. Okay, so let's look at the transformation. Let's touch on that. Okay, so transformation. Okay, so we're going to touch on this as quickly as we can. You can see here, right? So this is how your function is written, like this. You have a sine or you have a cosine, but you still have the same characteristics where your a is can cause it to stretch and vertically or compress vertically. You have your k, which will cause it to stretch or compress horizontally. You have your d that'll make it go left or right, and your c to go up and down. So it's similar transformation characteristics, okay? But you have to know how to use, you need to look at the definitions here though, right? So a is actually, we call it amplitude, right? K is actually helps you to figure out your period, right? So your period is equal to 360 divided by k. okay? And then your phase shift is going left and right, and then your vertical shift up and down, okay? So we always have parent functions, right? So these are your parent functions, the sine and the cosine. We actually saw it in the previous video, right? So at 0, we start off at 0, so x is 0, y is 0. Then we go to, this would be like a sort of like the unit circle graph. So if I start off at 0 for x, my y is 0. I go to 90. My y is, remember, these are all, the x is all degrees, by the way. The x is degrees. So if I go to 90 degrees 90, I'm at -1, sorry, 1, not -1, sorry, 1. And then I go to 180, then I'm at 0 for y, go to 270 for x, I'm at -1, and so on, right? So we know this from the previous lesson, okay? So now when we have transformation, right, we have to look at the parent function and how is the parent function changed to the transformed function, okay? So if I look at this one here, this one here, so 2, that means it's stretching by 2, right? My y value is going to go up by 2, multiply it by 2. And then over here, it looks like I'm going up and down. I'm moving up and down. There's nothing happening to the x, okay? There's nothing happening to the x. X is plain. So I have my parent function, and then what's happening? I'm stretching vertically by a factor of 2y, and then I'm also shifting up by y plus 1. So therefore, this is what's happening here. So each of my y coordinates on the parent function, I'm going to multiply by 2 and add 1. So over here, multiply by 2, add 1. Multiply by 2, add 1. Okay? And then when you graph it, you graph the transform function, you can see it moved up by 1. Also, it stretched it. Okay? There you go. So my x didn't change, but my y now is at 1 versus that being, sorry, when so my y used to be at 0 when my x was 1. Sorry, when my x is 0, but now my y is 1 when my x is 0. Okay, so it shifted. It stretched and it moved up. Okay, so now the question says, what's your amplitude? Well, the amplitude is going to be your a, right? So a is 2. Your period is going to be 360 divided by k. In this case here, k is 1, right? Because there's no value. So that you gotta say it's like an invisible 1. So k is equal to 1. So 360 divided by 1 is 360. So my period is 360, which makes sense. And then number of cycles between 0 and 360, it's 1 cycle. Okay, that's why we say k is 1. Okay, so now let's look at this next one here. This one's a little bit complicated. Right, this example here, you can see there's some movements here. I rotate or reflect around the x-axis, and then I have 1.5, so I'm going to stretch by 1.5, and then I have my shift on the x-axis by 30 degrees positive because the formula shows a negative here. Therefore, this has to be a positive number. So I'm going to go to the right by 30 degrees, and I'm going to go up by 0.5. So here, let's look at it. So A is negative 1.5, vertical stretch of 1.5, and vertical reflection. So my y's are going to be multiplied by negative 1.5. My k, in this case, is 3. So my compression is, remember, it's always 1 over k. So 1 over k means 1 over 3. That means I'm compressing it because I have a fraction here. And then my phase, I'm moving to the right by 30 degrees. So I'm adding 30 degrees to the x, and I'm adding 0.5 to the y. Okay, so looking at the parent function, and this is what you add to it, okay? So x divided by 3 plus 30. This is what you get. Okay? And this is what you get for your y. And then you graph it. Okay, so this is a transform graph. Then it's going to ask you what's your amplitude. My amplitude is my a, negative 1.5, or it's just, sorry, it is 1.5. It's not negative. My amplitude is 1.5. And my period is going to be 360 divided by k. So my period is 120. So that means each cycle takes 120 degrees to complete. So let's look at a graph. Does that make sense? So I'm looking at here 30, and then it repeats at 150. Well, the difference between that is 120, right? So that makes sense. My graph makes sense for my calculation. Okay. So I'm going to stop here because I think you kind of get the idea. I'm going to go to the next lesson. Okay. And then there's questions related to that. And then the last lesson, this is the very last lesson for Unit 4. It's just an application question lesson. So let's go through the application. Let's look at that. Okay, it's just basically here we're just remembering the unit circle. So remember that stuff from the previous lesson today, right? So remember this from before. So now let's get into the sine function, cosine function. Okay. Okay, so the cosine function graphs the relationship between the angle and the vertical displacement of x, and that was the sine function. The cosine function graphs the relationship between the angle and the horizontal displacement from the y. Okay, so let's look at an example. Okay, here is an example where we're modeling something in graph. So this is a Ferris wheel. Okay, so the Ferris wheel has a radius of 8 meters and turns counterclockwise. Okay, and the origin of the wheel, let the origin be the center of the wheel. Begin your sketch when the radius from the center of the wheel to your car is along the positive x. So, okay, so if I were to draw a circle bit of this, I'm drawing a circle, right? And so instead of a unit circle, I'm drawing a circle that's a radius of 8. Okay, so here's my circle here. So that means if my radius is 8, if I were to put the coordinates on each of these angles of 0, 90, 180, and 270 and 360, that means over here would be 8. This would be 8 and 0, 0 and 8, negative 8 and 0, and 0 and negative 8, and then back to 8 and 0. Okay, so if I were to do this, my graph would look pretty simple in the sense that the only difference between this and the unit circle, the parent function unit circle, is that my y is my radius is 8 times bigger. So if my radius is 8 times bigger, that means I'm stretching by 8. Okay, so if I'm plotting this, and basically just plot this, I have 0 at angle 0 is 0. At angle 90, I'm at 8. At angle 180, I'm at 0 again for my y. And then at angle 270, I'm at -8, angle 360. So that's sort of the graph there, right? There's no shift on my x or on my y, me moving it up and down, but I have my a is now 8 because that's my amplitude, right? So from here to here, my max height is 8, my min height is -8. Okay, so if I were to get the difference between the two and divide that by 2, my amplitude is 8. Okay, similarly, this would be your graph for your cosine. Okay, Now, if you were to look at between the cosine graph and the sine graph, they look the same. If I were to shift my cosine, if I were to move my cosine graph to the right by 90 degrees, remember everything repeats, right? So whatever I have here, let me just draw over here. So whatever I have over here, okay, on this side, it's repeating. Now, if I move this whole graph over to the right, this here will come over to here. And then this point here comes over to here. So you can see how then it's repeating. All right, here we go. So you can see how the sine graph, this looks like a sine graph right here. Right? If I move my cosine graph over 9 degrees, it looks like a sine graph, doesn't it? And that's what we're saying over here, the bottom over here. Let me go back to the bottom over here. We're saying that the sine graph and the cosine graph are the same. The only difference is you move the cosine to the right 90 degrees. They're the same, okay? So here is an example for you guys to look at of a problem. And this is going to be our last thing we're going to look at right here. A carousel rotates at a constant speed. It has a diameter of 15 and a horse that is directly in line with the center horizontally rotates around 3 full times. Create a graph that models this horizontal distance from the center. Okay, let's look at this. Okay, so my radius is going to be, this is diameter is 15, my radius is 7.5. So if I draw my circle, I have each of my coordinates, it's going to be at 7.5. So I have x 7.5, y is 0, so on. I go around the circle, and wherever I would have 1 in my unit circle, I'm going to have 7.5. Okay. Now, when I graph it, right, I'm graphing it based on what I see here, and we're looking at the horizontal distance. So since we're looking at a horizontal distance, we have to go back to here. When it's asking the horizontal distance, you're going to use the cosine. Okay. So now, since we're asking for the horizontal distance for this question, we're going to start with the cosine. It'll be a cosine graph. So this is a cosine graph. The only difference is that I'm at 7.5 versus when it was a unit circle, I was at 1. Okay. So that's your cosine graph. Okay. This one here, you know what? We'll go through this one. This is the last example, I believe. Yeah, we'll go through this example here. So a group of students is tracking a friend, John, who's riding on a Ferris wheel. Now, since you're looking at a Ferris wheel is vertical, right? Is vertical, right? So a Ferris wheel is vertical. This one here was not a Ferris wheel. This is a carousel, which is horizontal, right? So if you're doing vertical, I'm going to use a sine graph, right? A Ferris wheel goes like this, right? A carousel goes like this, right? Like a pony carousel if you go to Canada's Wonderland, right? So since we're talking about a Ferris wheel going vertically, so we're going to use a sine. But either way, you can use cosine or sine, because the difference between sine and cosine is the cosine shifts 90 degrees to make it a sine. Okay, so let's look at what we need here. What do we need here? Okay. John reached the maximum height of 11 in 10 seconds. And then he reaches the minimum height of 1 meter at 55 seconds. Okay, develop a sine and cosine function. So it's asking for both, which you can because the difference between the two is just 90 degrees. So what's our amplitude? Our amplitude is our max minus your min divided by 2. So our max was 11 and our min was 1 meter divided by 2 here, equals to 5. Our period, okay, we have to figure out what our period is, right? But I started off at, if you look at the graph, at 10 seconds, I was at the max. And then 55 seconds later, I was at the min. So if I look at the difference between the time it took me to get to the min and the max, it took me 10:55, took me 45 seconds. That means another 45 seconds will take me to the max again. So another 45 seconds will take me to 45 plus 5 is 100. Okay. So that means my period of time is 90. 45 to come down, 45 to come up. So it's 90. So my period is 90. So we look over here. So we start off, K is equal to 360 divided by period. So 360 divided by 100 minus 10, or I just know from there to there it took 90 seconds. So 360 divided by 90 gives you 4. So my K is 4. So I know my K, I know my A. So what else I need to know? I need to know my shift. I need to know my C. My C, the shift, is equal to the max minus the amplitude. So my max, remember C is the center line. So my max is, we say it's 11 meters minus my amplitude. My amplitude we said was 5. That means my C for this is going to be 6. So I know it's C is 6. And then now we're trying to find about your D. Okay, your D is, and your D is related to the max. So you're looking at my D is at 10 seconds. Okay. So 10 seconds, I'm looking at my max. Max was at 10 seconds. So in order to find D, so D cos, there's 2 D's now. This is something you have to see in the formula. I believe, ooh, it's not up there. So this is important right here. Okay. My D sine is equal to my D cos minus 90 divided by K. So this is a formula you should know. And I'm just going to circle it here. If you want to go from cos to sine, okay? So my D cos is related to my max value, and then my D sine is just my D cos minus 90 divided by K. K we know is 4, right? So then you get 12.5. So now we have all the things that we need in order to get the equation, okay? I know this was a tough lesson to get. That's why we have to go through the problem questions, okay? And then that's it for now. I believe I covered enough. You guys need to work on the worksheet questions. That'll help you. Let's go back to the home page first. Let me see how many guys are still there. 15 guys are still there. So you got the worksheets there, 1, 2, 3, 4. There's a quiz related to all this. There's also review questions here. It doesn't count for marks, but it's review to help you for the test tomorrow. Okay, review. And again, the test is tomorrow, or it's at midnight tonight, like after midnight, 12:01, it's open. So you can start working on the test at 12:01 midnight. Okay. You don't have to wake up in the morning and start. You can start working on it really at, at nighttime. Okay. And then you have the whole time until tomorrow at 11:59 p.m. So please go there and work on that. And I make sure you guys hand in your test. Okay, let me stop sharing my screen. And I'm gonna stop recording.